Okay, Mr. Rops here.
Mr. Cole.
And Miss Murphy.
Okay, and so we're going to find the equation of this parabola here. I'm going to do it two different ways. And the easiest way, I think, my preferred way is I like the vertex down here. I know that vertex is the point -3, -1. And so I'm going to use vertex form, which is y equals a x minus h squared plus k. And my vertex, I know, is this. So I plug it in, a, and I get x plus 3 squared minus 1. Now my problem is I need to find this a value. In order for my a value, what do I need? Miss Murphy, what do I need to find a?
You could pick another point on the graph and sub that in.
Do you have a favorite point that you want to use?
The y-intercept would probably be an easy one.
All right, so these are going up by 2, so this is 16. So 0, 16. So, oh, it goes up by 2s. Oh, 2, 4, 6, 8, 10. I made a mistake. What's my mistake, Mr. Cole? Do you see it?
Your vertex.
My vertex.
Yeah, it's going to be
the axis is going by
2.
2s. We have to read very. I'm going to put it in red so everyone knows that I made a mistake the first time.
Be careful with your scales.
With the scales. Okay, so we have 0, 16. We plug it in. So 16 is the y. A. 0 plus 3 squared minus 2. So
okay.
16 is equal to a times 9 minus 2. Add my 2, so I get 18 is 9a. And so a is 2.
Okay.
And so to finish off the question, write the equation. The equation will be y equals 2 x minus plus 3 squared minus 2.
Okay. Would you actually, do you need the y-intercept for this, or could you use any point on the graph?
I could have used any point. I could have used the x-intercepts here.
Yep.
I could have used this point that I know. I could use this point. Any point on the graph will find me the a value.
Apart from the actual, you can't just put in the
the
vertex again,
the vertex
right?
Wasn't
but
working.
any other point will tell you the stretch.
Right. Now, if the question said write in standard form, the only thing to do now is multiply this out. So it's 2x squared plus 6x plus 9 minus 2, which is 2x squared plus 12x plus 18 minus 2, and I get 2x squared plus 12x plus 16, which is a nice check. We had 16 as our y-intercept, and there's a 16. So that's one method. That's using the vertex form. A second method.
Okay.
What's your preferred method, Mr. Cole?
Okay. I actually quite like using the x-intercepts. So y equals a x minus p, x minus q. Okay. So on this graph you can see that the x-intercepts are at -4 and at -2. So what we need to do is x add 2 and x add 4. Okay, so we can just check when x is -2 now, that is going to make it y equal to 0, and
right.
when x is -4, that's also going to make y equal to 0.
Because 0 times all that is just 0. Super. Okay, so now we're going to choose a point. Should we choose the y-intercept again, or we want something more creative? Let's pick.
Well, we could choose the vertex, or we could just choose any old point, I suppose.
All right, let's choose this point just for fun, which is -5. This is the point, -5.
And it's 8, isn't it?
8.
No,
6.
6. Sorry.
It's okay.
Getting messed up with the scales again.
The scales, be careful with the scales. 6. So I'll plug that in. And so 6 is equal to a minus 5 plus 2 minus 5 plus 4. 6 equals a -3, -1.
Okay, so 6 equals 3a.
3a, and so a is 2, which we knew from before anyway. It's going to be the same equation. So y equals 2, x plus 2, x plus 4. And if we have to put it in standard form, which means we multiply it out. It's easiest to multiply the 2 at the end. Yep. I get x squared plus 2x plus 4x is 6x plus 8, which gives me 2x squared plus 12x plus 16.
I think we've got the same thing.
Is exactly the same thing.